All right, these are some more examples for u substitution. So we make our u equal to 3y minus 5. So we have options here. You have an entire denominator, but then we also have a parenthesis. And so that's where you want to focus on, whatever's inside that parenthesis. So now when we take it, we get du equals 3, and we write dy. So dy would be du over 3. Now, once we now take our u and our dy and replace them, everything should have no more y's in there. So this is 7 over, and that would now be u squared. And then it's du over 3. So everything looks perfect. We can now take our 7/3 out, rewrite it in our general power, and we do our integral. So if we add 1, that would be -1. And then that would be 1 over -1, which is just -1. And we should all know this by now. So this is -7/3. And then it would be 3y minus 5 to the -1 plus c. Rewriting it is -7 over 3, 3y minus 5. You can distribute if you want. I'm going to leave it alone. But what do we still need to do? We need to check it. So if I go back up to the top one, that would become 7/3, 3y minus 5 to the -2 times 3, which is the inside. And the 3's cancel, taking us back to the original. So that's perfect. Everything checks. So we just have to take the derivative. Okay, so this is perfect. Let's move on to the next one. So here we have a secant squared, and we have a tangent x plus 3. Now, knowing that this is now chain rule, you can also start to see things as what you're supposed to take. So we know the derivative of tangent is secant squared. So if we make our u tangent x plus 3, we know that the du would be secant squared x dx. And so now solving for it, we can now plug it in. So we have secant squared x, u, and then du over secant squared x. And you see it cancels. So remember, this is just the reverse of chain rule. So we want to look for the one that when we take the derivative of it will become the other one. So tangent will become secant squared. Everything works perfectly. So, oops, wrong color. We have the integral of u du, and that's just 1/2 u squared plus c. Plugging it in, we get 1/2, and now we can plug in the tangent x plus 3 squared plus c, and we check. So the 2 cancels the half, that's perfect. So we get tangent x plus 3, and then the derivative of the inside would be secant squared x. And there you have it. That's a check. And then we erase it. Everything's good. All right, one more. So we look at this one. You can see that we have an inside here, and we have an inside here. And so again, we're looking at derivatives of each. So if I were to take the derivative of 5t to the 4th, that would give me 20t cubed. Not this one. But if I take the derivative of t to the 5th, that's going to give me 5t to the 4th. That's my u. So my u equals t to the 5th minus 4t. So now when I take my derivative, you can see that I'm getting the other one. And so now you can even just come back into this, go, look, that and that is du. So I can take these two and just say, well, those are du, and then rewrite it. So this is the integral that we're going to get. So this would be the integral of u to the half du. So that would be u to the 3/2, 2/3 plus c. So it's 2/3 t to the 5th minus 4t 3/2 plus c. And if you take the derivative, you can already see that that 3/2 will come down and cancel. It's gone. We subtract 1 and makes that. And then the inside's derivative is this. So everything checks perfectly. There we go. All right, one more. So we have an outside and inside. Let's see if you can figure out what the u would be. Exactly, the x squared minus 4x. So if I take the derivative of it, it's going to give me something similar to that. And so it's not exact, but it is similar. So if you notice here, we now solve for dx, and we get du over 2x minus 4. So when I plug that in, everything should disappear. All the x's should disappear. You may see that there's something extra that you just have to do. Exactly, factor. So if I factor this, I now can cancel x minus 2. No more x's, everything is just u's. So we end up with 1/2, and then the square root, I'm going to move the u up and make it a negative 1/2. And there you have it. So now we're going to add 1, so this would be u to the 1/2, and so that would be 2 over 1 times 1/2 plus c. Rewriting, we end up with just plain old square root of x squared minus 4x dx. And so if we take the derivative, it'll kind of reveal why there is no 2x minus 4 here. What happened to it? So if we take our derivative, using this as a negative 1/2, positive 1/2, we would get 1/2 x squared minus 4x to the negative 1/2, and then times the derivative inside, which is 2x minus 4, right? Okay, so now you can see that that half came in and just canceled these, giving us x and 2, and that was our answer that we have over there. Now, I don't know why I wrote dx on there. It's plus c. There we go, I think because I was going to do the derivative of it, but there we have it. But always double check these to make sure that they work. So sometimes you will have to factor when you plug it back in.